Hi, so problem came up which is a little bit difficult to solve. This is on page 141, number 27, 2-6, chapter 2, section 6. So the problem has something like this. Limit as x approaches infinity of square root of x squared plus ax minus the square root of x squared plus bx. Well, whenever we have a goes towards infinity or negative infinity, you want to change this to a fraction if you can. And so, because you want to compare the numerator and the denominator. So how do we do that? Well, it's pretty simple if you think about it. It's if you want to change this to a fraction, just go put it over 1. And that's how you do that. Okay. So that's the first small little trick that you have to get used to. Change it to a fraction whenever it approaches towards infinity or negative infinity. So limit x towards infinity of square root of x squared plus ax minus the square root of x squared plus bx. Now what you want to do over that is usually when you have a binomial now, you want to multiply it by its conjugate, right? To get rid of the square roots. So square root of x squared plus ax plus square root of x squared plus bx. If you do it to the numerator, you have to do it to the denominator as well. And then let's see what happens. Limit as x approaches infinity now. We forward this out. X squared plus ax squared. Square root of that is x squared plus ax minus, and then the outer and the inners always cancel on excuse me, conjugates. So excuse me. So I used the last one as square root of x squared plus bx times x squared of x squared plus bx. You end up with minus x squared plus bx all over square root of x squared plus ax plus square root of x squared plus bx. You will notice something in the numerator. It always will cancel something out. So x squared minus x squared, because it's minus x squared right over there. So that canceled out. So you have a limit as x approaches infinity of ax minus bx all over square root of x squared plus ax plus square root of x squared plus bx. At this stage now, because the degree here is 1 for both of them, I'm going to divide top and bottom by x. So I divided by x here, divided by x, divided by x, divided by x. So you end up with a limit as x approaches infinity of a minus b, because the x's cancel here and there. And to get this inside the square root, I'll give you a little. If I have like 9, square root of 9 over 3, that should equal 1, right? Well, we can keep it in the radical if you go 9 over 3 squared. That also equals 1 as well. So you can put this inside the radical by squaring it. Square root of x squared plus ax over x squared. And break it up here. Plus the square root of x squared plus bx over x squared here. And this turns out to be, I'm just going to do this portion, square root of 1 plus a over x plus square root of 1 plus b over x. Now, as x goes towards infinity, this goes away and that goes away. As x gets really huge, this fraction goes towards 0. So I'm going to move this up here a little bit. So I have a minus b in the numerator over square root of 1 plus square root of 1 is square root of 2. And that should be your answer. Good luck with the rest of your homework and see you around. Thanks. Bye.